The function is defined on the closed interval -1 to 4 for lots of different choices. Okay, so if the function is defined, that means there is a point at the x value. So I just need to kind of see all the points that are in question. If I look at x equals 0, even though the graph is not connected, there is a point there because there's a dot at x equals 0. 1, we've got something going on, but there's something going on there. At 2, notice it's disconnected, and neither of those circles is filled in, so it is not defined there. And then the only other question that I'd maybe stick at would be 4, and there is a point there also. So the only place that it would not be defined at would be at x equals 2. So my answer would be D. Okay, 7. If f of x equals x plus 8 over x plus 2, when x doesn't equal -2, and it's equal to 4 when x does equal -2, which of the following 4 statements are true? Okay, first one, f of x is defined at x equals -2. That means that there is a point. And if I'm looking at this, I see an equal sign right here, so I know that it is defined, and I could actually just say f of -2 is equal to 4, because that's what it says that it equals. So this one is definitely true. Okay, the next one that says that it's continuous, so I'm going to look down at actually 3 first, because I know the conditions for continuity is that the point is defined and that the limit exists. So I'm going to test this one out first. So I know my limit as x approaches -2 from the left, it has to equal the limit as x approaches -2 from the right. And that basically is going to involve me plugging some information in here. I notice that if I try to plug -2 into the step function, I'm going to get 6 over 0, and which just can't be. And I could try to factor it, I could try to do anything. There's really nothing that I can do with this function. So I notice at x equals -2, the limit does not exist because I'm not getting an answer for that one. So the limit does not exist. So that one, no, does not exist. Okay? If the limit does not exist, the function cannot be continuous. If the function is not continuous, it cannot be differentiable. So choice 1 is the only one, which is choice A. Okay, 8. For which of the following functions do f of 0 and f prime of 0 exist, but f double prime of 0 does not? Okay, what this is talking about is I can get an answer for f of 0 when I plug in 0. I can get an answer for f prime when I plug in 0, but I can't get an answer for f double prime when I plug in 0. So I'm just going to go down here and try these out. Okay, so if I try to plug in 0 into this first equation, first of all, I don't like dealing with negative exponents, so I'm going to rewrite that as 1 over x to the 1/2. And you'll notice if I plug in 0, we cannot do that, so f of 0 does not exist. So I can go ahead and just cross that one right out. Okay, the next one is f of x is equal to x to the 1/3. First thing that I want to try to do is to find f of 0. And if I plug in 0 into that function, I'll get 0. So we get an answer, which is good. Okay, the next one I'm going to find f prime of 0. So if I take the derivative of this, it's going to be 1/3 x to the -2/3. And if I rewrite that, that will be 1 over 3 x to the 2/3. If I try to plug in 0, can't do it once again, so that one does not work. If I go to choice C, I have f of x is equal to x to the 4/3. If I try to find f of 0, if I plug 0 in, I get 0, so I get an answer. That's good. Okay, f prime of 0. When I plug in f prime, I'll be 4/3 x to the 1/3. And if I plug 0 in there, I get 0, so I get an answer. That's good. And then when I go to take the second derivative, I'll get 4/9 x to the -2/3, which can be rewritten as 4 over 9 x to the 2/3. And if I try to plug 0 into this one, I can't plug 0 into that one because I'll get 4 over 0. So no. So notice that I got an answer for f of 0. I got an answer for f prime of 0, but I could not get an answer for f double prime of 0. So C is my correct choice in this case. I'll just do one more just to show you how the other ones might not work. If I have f of 0 on D, if I plug in 0, I'll get 0. For the next one, if I take the derivative, it will be 7/2 x to the 5/2. If I plug in 0, I'll get 0. On the last one, if f double prime, if I take the second derivative, I'll get 35/4 x to the 3/2, and if I plug in 0, I'll get 0. So notice I actually got an answer for all three, and I wasn't supposed to get an answer for f double prime, so that's why C was my choice. Okay, number 9. If p is greater than 0 and q is greater than 0, then the integral from p to p plus q of dx over x squared is equal to what? Okay, first of all, I just need to clarify this. They're basically telling me that p and q are positive, and the only reason that they're telling me that is because if they equaled 0, then I'd have troubles because I wouldn't be able to plug in 0 in here. So that's the only reason that they told us that. So we can pretty much ignore it. Okay, so basically this problem is just asking me to find the integral. And I'm going to rewrite it as x to the negative 2 dx, because now I can use the power rule. I'm going to increase my power by 1, so I'll get x to the negative 1, and then do the reciprocal on the outside, which is negative 1. And then if I rewrite that, I'll get negative 1 over x, and I'm going to evaluate it at p plus q and p. So if I plug p plus q into this problem, it's going to be negative 1 over p plus q minus, when I plug in p, I get negative 1 over p. So that's going to turn it to plus. So I'll get negative 1 over p plus q plus 1 over p. And I notice that none of those answers match because they all have common denominators and I don't. So the common denominator is going to be p times p plus q. Okay, I'd have to multiply this part by p on the top and p on the bottom, so I'm going to get negative p, and then plus, if I need to get the common denominator on this one, I'd have to multiply by p plus q on the top and the bottom. And so 1 times p plus q will be plus p plus q. And then from here, I notice my p's cancel out, so I'm left with q over p times p plus q, which is choice E. Okay, last one. The limit as h approaches 0 of e to the 4 plus h minus e to the 4 over h. Now I'm guessing the first time that you see this problem, you're going to have absolutely no idea how to work this problem, but the next time you see one like this, hopefully you'll be able to. I'm going to bring up something that we haven't seen in a really long time, and that is the definition of derivative. The definition of derivative, where did my pen go? Well, sorry about that. The limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. That's the formal definition of derivative. And if you'll look at this, this actually looks pretty similar. I have the limit of a letter that's approaching 0. I've got a function, it's got 4 plus something minus something else over. So the format or the setup is the same, and since the setup is the same, this problem is basically just asking me to find the derivative. So this problem is asking me to find the derivative. We just need to figure out what is it asking me to find the derivative of and where. Okay, a couple things that I want to check. First of all, I noticed that they put 4s in here in place of the x's. So we're going to find the derivative at x equals 4. Okay, now the last part we need to figure out is what do I want to find the derivative of? So we need to figure out what our function is. Well, I noticed that in both of these, I have an e, so my function is actually e to the x. Okay, and we could just kind of think of that h as being an x. So basically this problem, even though it looked kind of weird and whatever, when you see a problem like this, it's only asking you to take the derivative. My function is e to the x. When I get my derivative, I'll calculate it at 4. So the derivative of e to the x, we all know, is just e to the x. And then if I calculate it at 4, if I plug 4 in for my x, I'll get e to the 4. So B is my answer.